3, and 4 often did not bloom during that first growing cycle, which created a sort of gap in our understanding of what was happening. We also saw kind of lower yields of polyphenols, flavonoids, and tannins at that time. But across all different soil types, we were able to confer that the Rama cultivar was actually the highest producing of antioxidants, including polyphenols, flavonoids, tannins, and vitamin C. And we're looking at the impact of processing. We're looking at how phytochemical development compares when we're comparing fresh frozen crops, freeze-dried crops, and oven-dried crops. So for polyphenols, for example, we saw that their values range between 0.2 and 3 milligrams of gallic acid equivalents when they were fresh frozen and had no other processing. However, when we freeze-dried those crops and used the same amount for the extraction technique, the values increased to a range between 2 and 13.5 milligrams of gallic acid equivalents. However, looking at oven-dried samples, we see that the range is much lower, and that indicates that that higher temperature is degrading those sort of antioxidants that we find valuable in our crop. Looking at trace metals and volatile components, ICP EOS results indicated that the Vana cultivar showed the highest aluminum, calcium, and potassium, whereas the Rama cultivar showed higher concentrations of copper, sodium, and zinc. All cultivars were also found to have trace amounts of selenium, which is another important element we're looking at. For GCMS results, we saw that each cultivar had eugenol in high concentrations. That was the most highly prominent essential oil found in our samples. But for Rama specifically, we found caryophyllene and beta-alanine. And for the Vana cultivar, we found trans-beta-ocimene, as well as caryophyllene, german green tea, and some fatty acids. The temperate cultivar was found to have the highest concentration and biggest variety of fatty acids, as well as estradiol, which distinguished it from the others. So moving on to the results for precise irrigation and how that affects the phytochemical development of our crops. So across the growing season, the following trends were seen. Crops grown in high irrigation and medium irrigation always were able to develop. In the first year of precise irrigation samples, we actually didn't see as much development in low irrigation samples, meaning we had less sample to also work with. So those samples also had the high irrigation and medium irrigation, had the highest concentration of antioxidants. However, we would see that those antioxidants would decline by the end of the growing season, making it less stable. So despite the lower irrigation crops having less growth, we did see overall that antioxidants would be higher in low irrigation at the end of the season. And we also saw that when we freeze-dried our crops, there appeared to actually be very little difference in concentration in tannins, for example. So when looking at GCMS and ICP EOS for this, we saw the same essential oils and volatile compounds in the Rama cultivar as those that were grown at the different farm. We also saw that trace metals overall peaked in October, with medium irrigation tending to have the higher level of trace elements. So in conclusion, we found that the Rama cultivar shows the highest potential for growth in the state of Maryland. It was the only cultivar that would consistently grow throughout the different soils and throughout the growing season. The high temperature extraction and processing can cause phytochemicals to decline. We have seen this happen in other fruits that we're researching in our lab, including Rhenium naturini. So it makes sense that these chemicals would still remain sensitive, but in a different crop. We found that high irrigation allows for the crops to initially thrive. However, if you plan to just sort of let your Tulsi grow over time in order to get the highest yield you can from it, medium irrigation would be best for long-term growth. And finally, antioxidants and present essential oils in the crop can provide a wide range of health benefits, including positive cardiovascular effects, anti-inflammatory effects, but it can also be used in non-traditional methods, such as a pesticide or anti-fouling agent. So the future plans for using Tulsi in Maryland include creating an organic pesticide using either the essential oils or present antioxidants. We also plan to isolate compounds found in Tulsi for non-medicinal purposes, such as anti-fouling. And finally, we plan to create health products such as health drinks and snacks using Tulsi. And these are the references used in my study. And I would like to thank my committee members, Dr. Volkes, for being here. I'd like to thank Dr. Zebula for his help with the GCMS, the UMass Demonstration Farm, Ms. Henriette Denoden, USDA NIFA Evans Allen Grant, Navy MSI Grant, the EKIP Free Grant. And thank you all for your time.